The universe, an inconceivably vast cosmic abyss stretching for billions, and perhaps trillions, of light-years in all directions. As a biological species tethered to our blue planet, the dimensions of the universe simultaneously awe and terrify us. Size is what embodies the universe, and the further we peer into it, the larger structures we discover. Perhaps we will never know what lies beyond the observable universe, but we do know which structure is the largest within our universe. It's the Great Wall of Hercules, the Northern Crown, also known as the Thread of Galaxies or the Galactic Wall. This colossal structure contains various astronomical objects, stars, galaxies, gas clouds, and matter. Not too long ago, a series of gamma-ray bursts were also recorded here. Gamma rays are a form of intense, penetrating electromagnetic radiation that results from the annihilation of electrons and positrons during the decay of elementary particles and atoms. Gamma rays have the shortest wavelengths among all electromagnetic waves. Therefore, gamma rays are the most destructive and powerful waves in the electromagnetic spectrum. These rays constitute a form of ionizing radiation and are thus biologically hazardous. On Earth, they can damage bones, internal organs, cause radiation sickness, various oncological diseases, and so forth. On cosmic scales, gamma rays can destroy entire planets and star systems. The gamma ray burst is a relatively narrow beam of extremely powerful radiation lasting from a few milliseconds to several hours. Gamma ray bursts occur very rarely, perhaps a few times in a million years, and all outside our galaxy. But after the initial brief burst, a long-lasting afterglow is emitted. This is what we use as a cooling sign to determine where and when the gamma ray burst occurred. It is believed that most gamma ray bursts occur during the merger of two neutron stars, a black hole and a neutron star, and during the death of massive stars in supernova explosions. When a massive star collapses and explodes at the end of its life, turning into either a neutron star or a black hole, the shockwave from this collapse releases an enormous amount of electromagnetic energy. It is believed that gamma ray bursts, known as short bursts, occur a few seconds before the collision of two neutron stars. The tidal gravitational forces between two stars are so strong that their outer layers are torn apart, releasing a tremendous amount of energy. Gamma ray bursts are the most powerful explosions in the universe. More energy is released in a few seconds than our sun generates in its entire lifetime. Thus, we can detect them during cataclysms from billions of light years away. Gamma ray bursts are associated with a multitude of phenomena, but what we didn't expect from them is a visible connection with inexplicably large cosmic structures. Short gamma ray bursts occur less frequently than their larger counterparts. Therefore, we can assume that most bursts are the result of supernova explosions from massive stars. As a result, we can expect that the distribution of gamma ray bursts will be associated with regions containing massive stars that form in areas with higher matter density than typically found in interstellar space. Massive stars are formed within dense gas and dust clouds. However, when we detect these bursts not just in individual galaxies but in entire galaxy clusters, they leave us perplexed. The immense galactic walls and other locations where gamma ray bursts occur are difficult to explain with our current understanding of the universe. Nevertheless, they characterize the largest object ever discovered, known as the Great Wall of Gamma Ray Bursts, or the Great Wall of Hercules-Northern Crown, within which 19 gamma ray bursts have been registered. These gamma ray bursts were detected in an incredibly dense cluster spanning billions of light years. The Great Wall of Hercules-Northern Crown derives its name from the constellations through which it passes. As one might guess from the name, these constellations are Hercules and Northern Crown. In reality, it spans 20 constellations, including the constellations of Draco, Lyra, and beyond to Gemini, within which the gamma ray bursts were actually recorded. It is difficult to fully estimate the size of this structure. Its observable length is estimated to be approximately 10 billion light-years, while the observable universe has a diameter of 93 billion light-years. Thus, the Great Wall of Hercules-Northern Crown constitutes roughly 10% of the universe's diameter. This structure dethroned another record holder, the Huge Quasar Group, consisting of 73 quasars and having a diameter of 4 billion light-years, making it one of the largest structures in the observable universe. In the Great Wall, 19 gamma ray bursts were registered, which are relatively close to each other on a cosmic scale. This significantly exceeds the expected frequency of gamma ray bursts that astronomers have observed in other parts of the universe. While the gamma ray bursts are the defining feature of this discovery, astronomers speculate that this cluster may contain up to 4 billion galaxies. The question is how many of these galaxies are a product of this structure and are under its gravitational influence. But regardless of whether it is gravitational or associated with the structure, the mechanism of motion and interaction over such vast distances in such a short period of time remains open. To this day, the Great Wall of Hercules-Northern Crown is the only structure with a size of 10 billion light-years, while the age of the universe is slightly less than 14 billion years. This, in essence, is the mystery how such a colossal structure could have formed in such a short period of time since the birth of the universe. The Great Wall was discovered 10 years ago, in 2013, by an international group of astronomers as part of the SWIFT mission. The SWIFT Space Observatory, launched by NASA in 2004, was designed for the detection and mapping of gamma-ray bursts. Perhaps the most enigmatic and intriguing discovery lies at the heart of this research. Using this observatory and several other telescopes, astronomers detected 283 gamma-ray bursts and categorized them into groups based on their redshift, referred to as subsamples. In this way, researchers gradually increased the number of subsamples to search for hidden patterns in their data. When astronomers used 9 subsamples, they noticed that 19 out of 31 gamma-ray bursts in one subsample were concentrated in the second, third, and fourth galactic quadrants. 14 of them are concentrated at approximately 45 degrees of the sky, which corresponds to a distance of approximately 10 billion light-years. Based on this distance, astronomers were able to estimate its presumed length. Considering that gamma-ray bursts are extremely rare and occur only as a result of sufficiently massive dying stars, such a distribution over such a vast distance was deemed unlikely. Therefore, the team considered the possibility that they had discovered a record-breaking colossal structure compared to any others seen in other parts of the universe. Through mathematical calculations, researchers concluded that the concentration of such a number of gamma-ray bursts in a space of 10 billion light-years is extremely improbable and is a random occurrence. This implies that something must be responsible for it. Such gamma-ray bursts are more likely to occur within some gravitationally linked structure, and the only known structure to us with a size exceeding 10 billion light-years is the Hercules-Northern Crown. As we have established earlier, gamma-ray bursts are products of the death of massive stars, and groups of massive stars form only in regions where there is ample matter for their formation. Therefore, a high concentration of gamma-ray bursts may indicate the presence of a population of massive stars of the same age but in intergalactic space. Thus, it may suggest that in this region of the early universe, there was more matter available for star formation. Over billions of years, they formed a structure, which is now known as the galactic filament or supercluster complex. However, this must be an exceptionally massive filament. Even if we remain impartial about how large objects can be in the universe, the Hercules-Northern Crown still remains extremely anomalous compared to other structures in the universe. Clusters themselves can grow to unimaginable sizes, such as our Laniakea supercluster, spanning 520 million light-years. But the Hercules-Northern Crown wall dwarfs even that. Isaac Newton postulated that when viewed on a large scale, all the energy and matter in the universe appear uniform. There may be deviations and voids, but they are small and localized. However, Newton's assumptions were based on the knowledge of the 17th and 18th centuries. Nowadays, we know that the distribution of matter after the Big Bang and cosmic inflation leads to theoretical and actual resizing of structures on scales slightly over 1 billion light-years. Over the past few decades, we have indeed found not one but several structures that challenge Newton's theory. Redshift analysis has revealed quasar groups and galaxy filaments ranging in size from just over 1 billion years to 5 billion years. One might expect that the principle of uniform matter distribution is incorrect or that our benchmarks are too low. It is also possible that matter was unevenly distributed after cosmic inflation, and perhaps some areas have more matter for star birth and galaxy formation, enabling the formation of such enormous galactic threads. However, in the case of the Great Wall of Hercules-Northern Crown, even if our calculations are incorrect, a structure larger than 3,000 megaparsecs in diameter still appears immense, considering our current observations of formations in the universe. The Great Wall exceeds the size of the next largest object ever discovered by more than 2 times. Some researchers argue that there are many such structures in the universe, and perhaps there are even larger structures. Unfortunately, we can currently observe only this part of the universe and see structures located in this region, as our telescopes cannot observe the direction blocked by the Earth, the Sun, and the avoidance zones in the center of the Milky Way. Something similar to the Great Wall of Hercules-Northern crown and such gamma-ray burst may be lurking in the shadows of the night sky. Certainly, our observation methods have been tested and refined to be as accurate as possible. It has been noted that the region where the Great Wall was discovered is surveyed almost twice as frequently as others. However, this does not provide an explanation for clustering by other means. So, the Great Wall, though real, was formed by some unknown method of creating such structures. Perhaps, as we learn more about other giant structures in the universe, such as the Sloan Great Wall, the Hercules-Northern crown wall will appear less anomalous. But in any case, it contains billions of galaxies, which means we can observe such gamma-ray bursts here and in other similar regions of the universe. Perhaps if our planet were located in another galaxy, we would not see such a high concentration of galaxies. But here on Earth, in just a few decades, we have made remarkable progress. And when we learn to understand big things, will we be able to understand how we fit into this unfathomably vast and complex cosmic system? A structure at 10 billion light-years is an immense distance that is difficult to fully comprehend. It accounts for a significant portion of the observable universe. But what lies beyond the observable universe, no one knows for certain. Is the observable universe really millions of times larger in volume than what we can observe? The Great Wall of Hercules-Northern crown is evidence that the size of the universe is enormous even in the face of all our assumptions and theories about the ultimate sizes of structures in the universe. Perhaps, somewhere far beyond our segment of the universe, deep in the cosmic web, there are structures that we can barely begin to comprehend. As numbers grow, we can lose sight of both massive structures and the scale of our own solar system, which is almost unfathomable for our species tethered to our tiny blue planet. But the solar system is just a tiny speck in our galaxy, and our galaxy is just a speck in the galactic structure of the Laniakea supercluster, which is barely noticeable compared to the size of the Great Wall of Hercules-Northern crown. But perhaps even this Titan's creation is nothing compared to other larger structures and the vastness of the universe. Well, that's all for today. Write comments, give likes, and share this video with friends to get as many views as possible.